Click the bell icon to get latest videos from Ekeeda.
Hello friends, let's see one more question on construction of NPDA. Over here, we are given with one question in which we have to compare the string and we have to find if it is in the form W, C, W reverse. The alphabet is A and B. We have already solved W, W reverse in which we were using the non-deterministic power because we never know where is the middle of the string. But in this particular question, C is used to represent the middle of the string. So we have to compare the palindrome from left side to the right side only when we have C encountered. Let's start with the construction of NPDA. The idea we're going to use over here is whenever we have an A, we will push, let us say 0. Whenever we have a B, we will, let's say, push a 1. Initially, the stack would be Z. A on a Z would get 0Z. Similarly, B on a Z would get 1Z. Once we encountered some A or B, there might be some 0 or 1 on the stack. So we will have transition for them as well. A with a 0 will become 0, 0. B with a 0 will become 1, 0. Similarly, A with a 1 will become 0, 1. B with a 1 will become 1, 1. After these symbols, we might be encountering a C. C means we have encountered the middle of the string. The top of the stack may contain either 0 or 1. We have to keep the zeros or 1 as it is. And go to the new state Q1. Once we reach Q1, that means we have seen some A's or B's and we have encountered the C. Now we need to compare it with the reverse, that is WR portion. So basically Q1 will have all pop-up operation. Let us say we encountered a A. To match with A, we should have a 0 onto the top of the stack. And we will pop it off. Similarly, we may have a 1 on the top of the stack, for which we should have a B. We will simply pop it off. Once we are done with the comparison of W with R, and we have seen C as well, now we can go to the final state. For that, we will be entering the empty string because the input string would be finished by that time. The top of the stack would be Z. We will keep it as it is. And let us say Q2 is the final state. Over here, we have not considered when C is visited, it is possible that we have not visited any A or B. So considering that, the top of the stack would be Z. Including that, on a C, if Z is the top of the stack, keep it as it is, move to Q1. With this, we have constructed the required NPDA. Now, let us see the components. Now, let us write down the transitions. Now, we need to insert the transitions for A and B when the top of the stack is 0 or 1. We need to simply push 0 for every A and 1 for every B. Once we encounter a C, we need to move for every symbol, either it is 0 or 1 or Z on the top of the stack. Delta of Q0. Let us say we have encountered C with, let's say, A was the last symbol, so it will have a 0. Keep it as it is and move. So it will be going to Q1, keeping 0 as it is. Similarly, we will have for 1 as well as Z. Let us write transitions from Q1. On Q1, with every A, we will pop off a 0, and with every B, we'll pop off a 1. Instead of delta, we need set notations over here. We are left with one more transition. Delta of Q1 on encountering end of the string, epsilon. When we are left with only Z on the stack, we'll go to the final state, which is Q2, keeping Z as it is. Next component is Q0, which is the initial state over here. Z was the top of the stack initially. Final state F that we are going to use over here is Q2. So we have defined all the components. Now let us try to run one string on this machine. Let us say the string that we are using is ABCBA. We are using instantaneous description notation, that is ID notation, in which we are using configurations of the states. Initially the state is Q0. The string is not visited yet. It would be ABCBA. And the top of the stack would be Z. On the first transition, it will be on state Q0 only. As A is already visited, it would be BCBA. Now the top of the stack would be 0. We will go to the next configuration. Again Q0 with CBA left out. Top of the stack would be 1, which will be pushed on. In the next transition, the state would be again Q0. Again in the next transition, the state would be Q1. As we are encountering C, the input left out would be BA. On seeing a C, we don't need to push or pop anything, so we keep 10Z as it is. Again in the next transition, we have a match of B with 1, so we'll pop off the 1, keeping in Q1 only state. Input left would be A with 0Z left out on the stack. Similarly, in the next transition, there would be a matching of A and 0. State would be Q1 only. Input left out would be epsilon. And stack would contain Z. Finally, the transition would be on Q1 with empty string and Z as the top of the stack. It will go to the final state. Over here, Q2 is the final state. Empty string would be left out, keeping Z as it is. At the end of the string, we are achieving the final state, and hence the string is accepted. Instead of this, if we take some string which is not belonging to the language, it would be going to any dead configuration, and eventually that particular string would be rejected. With this, we have constructed one more NPDA. Now we will see construction of more NPDA in the coming videos. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.